All right, so today we're going to take a look at some periodic trends. The goals will be to discuss and determine why these trends happen based on the atomic structure and what we've talked about with electron configuration. We'll look at atomic radius, we'll look at shielding effect, ionization energy, electron affinity, metallic character, and electronegativity. We'll start with atomic radius, which is the distance from the nucleus to the outermost or valence electrons. This is going to be determined by the principal quantum number and then also by the number of protons. So atomic size will increase as you go down the periodic table or down a group because you are increasing that principal energy level. So you're going 1, 2, 3, 4, 5, so you're increasing how far away the electrons are from the nucleus. As you go across the periodic table or across a period, the atomic radius will actually decrease. This happens because there are more protons as you go across a period, and so those protons will have more of an attraction to the electrons, making the radius smaller. This is an image that just shows you that general trend. So let's go ahead and practice. You can go ahead and pause the video and then play it again so that you can see the answers. So which one is bigger? You have carbon is bigger because it's further to the left, it decreases across a period, and it increases as you go down a group. So let's talk about shielding effect. If we think about electrons, they are going to both be attracted to the nucleus because of the positive protons, but they will also be repelled by other electrons. That repulsion can come from electrons in the same energy level and same orbitals, or it can come from inner energy levels. And the shielding effect is going to impact how big the atom is, and then it can also impact how easy it is to remove an electron, which is related to ionization energy. As the atom gets bigger and more sublevels are added, then the inner electrons tend to shield the outer electrons more. So what typically happens is that in addition to the fact that it's getting bigger just because it has more energy levels, you're also going to see it bigger because of the shielding. What also can happen here, though, is that as it gets bigger, now it's being shielded and now it's easier to remove that electron. And so the ionization energy will be lower, or it's easier to remove that electron and easier to form that cation. This can be counteracted by an increase in protons in the nucleus. As you increase protons, it's going to have a greater pull on the electrons, and so it might impact it and balance it out. Again, shielding impacts how easy it is to remove an electron, and then also impacts that radius as well. Let's go ahead and take a look at ionization energy. So this is the energy that's required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. So if we're looking at sodium, you would add ionization energy to remove that electron. Ionization energy in general will be positive as energy needs to be added in order to remove the electron. So this is an endothermic process. A lower ionization energy means that the element or the atom tends to form a cation because it's easier to remove that electron. And then a higher ionization energy tends to mean that it's going to form an anion because you're not going to be able to remove that electron very easily. When we look at trends, we think in general smaller atoms are going to be more difficult to ionize because the orbitals are closer to the nucleus. So there's an attraction between the protons and electrons. So it's going to be generally harder to remove that. As you move across the period, the ionization energy will increase, meaning that it's harder to remove that electron. The radius is smaller, so the pull is greater on the electrons, and it's harder then to remove them. As you move down the group, the ionization energy will tend to decrease because the electrons are going to be further away from the nucleus. So it's going to be easier to remove that electron to form a cation. There's going to be increased shielding from the inner electrons, so less of a pull from the nucleus, and then just the radius in general is larger. After you remove the first electron, the subsequent ionization energies are going to be higher. So after you remove that first electron, it's going to be harder to remove other ones. This is because there's going to be a stronger pull from the protons since you've removed one of the electrons. You'll see an especially big jump after the valence electrons are removed. So you remove the valence electrons, and now you're at those inner electrons, so shielding is much more reduced, and it's going to be a lot harder to remove those electrons. This is just a general kind of trends that you see. There are exceptions that happen in ionization energy, and this happens, you can see this over here kind of with oxygen and sulfur, how nitrogen is higher than what oxygen would be. The reason why this happens is because whenever we are filling our orbitals, if you think of electron configurations and orbital diagrams, oxygen is the fourth electron in that p sublevel, and the p sublevel has 3 orbitals. So oxygen is the first electron to pair up. This means that there's going to be some more repulsion from the electrons in that orbital, and so it'll actually be easier to remove that electron compared to nitrogen, just because it makes it more stable. Now, that doesn't mean that oxygen loses electrons, that just means that it might be easier for it to lose electrons compared to nitrogen. Here's just another, so ionization increases across the period and decreases down the periodic table. So why don't you go ahead and pause the video and practice. We'll choose the element that has the higher ionization energy, meaning that it's harder to remove the electron. So here are your answers. Ionization energy increases across the period and then decreases down the periodic table. So looking at another trend, we look at electron affinity. This is kind of the opposite of ionization energy because it's going to be the energy that's required to add 1 mole of electrons to 1 mole of gaseous atoms or ions. So electron affinity is normally negative because the first added electron is going to be added because of an attraction between the nucleus and that electron, and energy is going to be released. So this would be an exothermic reaction. However, the second electron that would be added, that electron affinity will always be positive because it's going to be hard and require energy to add that second electron to something that's already negative. When we look at electron affinity, the general trend is that we will decrease down a group, meaning a smaller negative number down a group, and then we will increase or get a larger negative number across a period. There are a lot of exceptions to this, but in general, this is what happens. So fluorine, for example, would have a really high electron affinity, meaning that it has a large negative number because it's really favorable to add or to gain electrons. We've talked about how fluorine is really, really reactive, and it really wants to gain that electron. This is because it has a high electron affinity and a really big attraction for those electrons. If some element has a high electron affinity, meaning a very negative electron affinity, then it means that it tends to form anions. Let's go ahead and practice. You're going to select which element is more favorable or more negative electron affinity. So which one's going to tend to gain the electrons more. So go ahead and pause, and then you can look at the answers. So here are your answers. Electron affinity increases or becomes more negative as you go across the period, and then would increase as you go up a family or decrease as you go down a family. There's a ton of exceptions to this, but this is the general trend. Okay, so electronegativity is very similar to electron affinity. This is going to, however, refer to how elements act whenever they are sharing electrons in a covalent bond. Electronegativity is the ability of an element to attract electrons within a covalent bond. Generally, the more protons that an element has and the smaller that it is means that it will have a higher electronegativity. It's going to increase across the period from left to right. So that means that the highest electronegativity, or the atom with the highest electronegativity, is fluorine. It will decrease down a family or down a group, meaning that they have less of a pull on the electrons if they're in a covalent bond. We also look at metallic character. Metallic elements are on the left-hand side of the periodic table. Metallic character increases as you go down the periodic table. This is, do they have properties typical of a metal? Do they tend to lose electrons in a chemical reaction? Metallic character increases going down the family. This corresponds to the increase in the atomic radius and a decrease in the ionization energy, so they tend to lose those electrons. And then it decreases across the period. This is because of decrease in size, increase in ionization energy, meaning it's harder to lose the electrons, and it's more favorable to gain them. This explains the general trends. You can go ahead and pause and practice. So here are your answers for that. And then finally, it might be a good idea just to summarize what each trend means and then why it occurs.